Hello everyone, I am Andrew Trappin, and today we talk about Git. My expectations that people who are listening to this stream right now or maybe later already experienced with Git at least on the basic level. Can create a repository, commit, view history using git log or something like that. And the goal for today's stream is to make your Git usage and also my Git usage more intentional and thinkful and also fearless. So we will understand some basic concepts and ideas that will help to make our usage more meaningful and thinkful. And the idea, important idea that Git is not just a tool for making few copies of your source code. It's integral part of your development workflow. That means that even a committing process is a part of development process. Because, for example, if you make some code which smells and try to commit it in an atomic, meaningful way, you probably will get some troubles. Because some parts of this code is interconnected and you can't spread it among few commits. And it will show you that there's some problem and you have to rewrite your code before committing it. And also committing allows later to find bugs easier and reasons why this change was introduced by someone and so on. So it's not only about creating code but also debugging, and debugging takes probably most of your time spent on the project, on a big project and long living one. So hello everyone, Alexander, and probably some who not typing in the chat. Let me switch to my notes and let's start from the picture. The picture, the comics about using a Git. The guy talking that there's some version control system that allows to track a collaborative work, and it has a good theory, mathematical theory behind it, and it's very cool. And after someone asks him how to use it, he says, I don't have any ideas. We just type few shell commands and hope for the best. And our goal for today is not to be this guy. We will try to make our Git commands or maybe any other interface to do very intentional things. So we understand what is happening under the hood. And first thing that we need to talk is commit messages. The commit messages is a very important part because it later will be used for debugging purpose or just for understanding the reasons why such a part of the code appeared. And here just an example guide which pretty short, 10 minutes read, and just explains basics of how to write a good commit message and reasons why you have to do it. So I already expect that you know it and can do it quite good. And we already have a repository with some history, and it's good. Probably one of the most important things about the history, it should be consistent and meaningful. So it doesn't matter what style you use, but everyone who contributes to this repository should stick to this style. And after that, we can do two basic things with the repository. We can see the status of it, and we can navigate the history and use this history to do our work. And I will be using a Magit or Magit interface. It's Emacs interface for Git. You can use any graphical or CLI or any other interface for Git. But I will be using this one because I spend most of my development time in the Emacs, and I'm quite used to this interface. And it's actually very efficient, in my opinion, of course. The basic screen, status screen, looks like that. I call it with magic status, or a hotkey you can see in the parentheses. You can get almost the same information typing git status in the command line, and few other commands like git log and maybe git stash and so on. This one represents all the necessary information about the current state of the repository. Maybe not the all, but most of interesting for everyday user. And here you see a few headings: untracked files, unstaged changes, stashes, and recent commits. And there are one more section called staged changes. Here I staged a file, and now you see one more section here. And first three sections are most interesting for us right now, because it's most fundamental thing about the everyday Git workflows. First of all, you create files in your working tree. Actually, you need to create repository first, of course, but you have already created repository, and inside this repository you create a file, and it is untracked file which resides in your working tree. Actually, you can have few working trees, but it's a more advanced topic that we won't be covering today. For now, we assume we have only one working tree, and we have few untracked files. After we created few files, we can add them to the repository using git add command, or for magic it will be s command, which will stage the files, and they will appear in the staged changes section, and after that we can commit them. And after we committed files, they will become a part of repository. Actually, there are few more things that are part of repository, but I will be calling a part of repository something that you can share with others. That means if you make any git pull, git push, or pull commands which exchange changes between different repositories, and if those changes are shared, this means that they are part of repository. Other technically belonging to repository things like stashes or unstaged changes, I consider as temporary state which belongs only to a local copy of repository, so they are not an actual part of repository in the global sense. Okay, we found that we have three types of files: untracked, staged, and unstaged. What unstaged files are? It's actually some files that was staged, but later they was changed. And difference between unstaged changes and staged changes is important, and we will be using it quite often. Staged changes is something that is prepared for commit. So the next commit command will take all the staged changes and will create commits from them. So we do some changes, and after that, after we decided that the some part of the work is ready to be persisted, we stage this part of the work and commit it. Let's take a look at how we can use already committed stuff, and later we'll do actually committing and other history related operations which create our Git repository and which integrates with our development workflow. First and most obvious command is status, which shows the current status of the repository, but the second one, which shows the history of repository, is git log command. Actually, I will open a special buffer which will show some of the commands that I use. For some reason it doesn't show commands which doesn't modify the history, but at least it shows something. Here is the output of log command. You can do almost the same in your terminal, but I already said I will be using Majit interface. And here you see the list of all commit messages in current branch. And each commit message already somehow useful on its own, but we can see not only commit message but the changes that this commit brings. We just open this commit and see the diff related to this commit. For example, the commit which add translation macro to format call actually adds a commit macro and import for the namespace where this commit macro defined. It's a first and most simple and probably efficient way to navigate the history of the whole repository. And one small trick that I want to show you, it's command called Majit diff toggle refine hunk, which shows highlights some changes inside the string. And you can see that only these dark green parts are changed between two lines. It can be useful if you review a long diff with a lot of text changed, and it highlights exact parts where the text was changed. But in most cases, we don't want to see the whole repository of the whole history of our repository, but want to see some particular part about changes for some file. And we can call git log command for one file. I will be showing it inside Majit, but it should work also to git log command. And for git log command, the options can be found in the manual. I won't be exploring them right now, but you can limit the list of the files you want to see history for. And here I see the history, which is applicable only for Emacs XYZ SCM file. And here in the header of the buffer, you see that it's commit history only for this file. And sometimes it's very useful to see the commits touching only this file. So you can track the history of changing of this file and why some changes appeared and disappeared. Sometimes I want to see the changes which more precise. For example, I want to see only changes that is authored by me, for example. And I will limit the list of commits in commit history with after equal to myself. It will take some time because I'm currently streaming and doing it at the same time. And you see I introduced only 6 commits to this file, and all those commits following the same style, both commit messages and actually the content of the commits. . And now I know all the changes that was introduced by myself to this file. But more frequently, I use more precise tool which shows the changes, which touches the exact lines of the code. And here we can use a blame function, which shows the after of the change for the exact line. Here I was on the description of the package, and now I see that this package was created by Nicholas during update of embark package. And I can see the actual diff that was introduced by this commit. And we see that it's probably just shifted their text, but also we can see the description changed using the function I showed you earlier. Those changes was actually introduced during this commit. That means it's not only shifted indentation, but also changed the description itself. Okay, actually we can use more advanced tools, but in most cases those is most frequently used. After we discussed this very basic but very often used tools for navigating history and finding the after and reasons for these changes, I will show you few more tricks related to the status buffer. Let's open the status buffer for my RD repository. Whoops. And this status buffer is quite big, and actually navigating through all the lines is takes some time. There are built-in hotkey called J, which allows to jump to some sections. For example, jump to stashes, JZ, jump to untracked, JN, and so on. It's good, but you see that I have quite a lot unstaged changes here, and I want to jump to exact line, to exact file, and to see the changes for this file. I can do it with search and try to search for features blah blah blah, but it will expand diffs, and the search will go through the file names, but also through the content of those changes. And there is imenu command, which also works for Madrid status buffer, and it allows to search through the commits. So I can specify for recent commits the content of commit message. For example, I want to see all the changes related to home services and to the shepherd. And here I minimized this list to those few commits. But actually I wanted to see changes, unstaged changes related to my features Emacs file. And here we go. We navigated to exact modified file in unstaged changes. And here we can see all the changes related to this file. But more importantly, we can not only see, but also can stage these changes. These changes or only part of those changes. For example, here in my configs file, I want to persist those changes. I added a few packages. I want to persist those packages, and those. Good. And now I jump to unstaged, to actually staged files, or more precisely to staged changes, and see that what will go to my next commit. And we see that those packages will go to the next commit, and I'm quite satisfied with this, and I will create a new commit. We're doing a very basic thing. We're committing the changes, but we do a little advanced technique here. We commit only part of the stages of the changes. We commit a hunk, or actually a part of the hunk. It's possible to do with CLI, but with CLI to pick those parts of the files, you will need to specify line numbers or something like that. But Majit allows to do it more visually and more pleasant and efficient, in my opinion. And here we can say that rd examples abcdw add few Emacs packages. Good. We wrote commit message, and now we just type Ctrl+C to get those changes committed. And we see that we have one unpushed commit here, which is in our local repository, but not in the remote. Actually, I have two remote repositories for this project, one on GitHub and one on SourceHub. And both of them doesn't have this commit. Cool. But I have a lot of changes, and some of them quite sophisticated, so I don't want to lose them. And to make sure that I won't lose them, I will be using a stash. Stash is very easy to use, very cool feature, which allows to save temporarily some changes in special object called a stash, and after that you can restore from this stash, or create branch from the stash, or create patch from the stash. And be sure that those changes won't be overridden by some commands, destructive commands like reset or rebase. To be very precise, they are not destructive, because the actual objects for those files will be stored in your Git repository, in your local copy of Git repository, but they will disappear from your branch, and it will be a little involved and hard process to restore those changes. So the easy way to take all the unstaged changes and to stash them. I will open the buffer, which shows the command that corresponds to the actions I do right now. And for stash, I will type z hotkey, and I will stash both index and Worktree. Worktree is unstaged changes, and index in this terminology is staged changes. So let's stage some changes, for example this one, and type zz for stage both, and let's type a stash message to distinguish this stash from different one. Some changes that have to be safe. Now we have two stashes, one which was previously created by myself, and the new one that I created right now. And now what we can do, we can apply those changes which is stored in this stash. We can see those changes as the basic diff, and let's apply them to our current repository by typing z apply, and you see the comment that corresponds to the section git stash apply, and we see all those changes are restored. There is another action called pop, which is equivalent to the apply action, and after that removing the stash. So it's combination of apply and drop actions at the same time. And now we can be sure that if even we do some crappy stuff with our files, for example, we remove all unstaged changes and staged changes too, we can restore all the changes from the stash. Z apply again, and our changes got restored. Hi pandemic, it's actually almost evening for me. What is your time zone? Good. We found that there is a very simple tool that allows to make our life much more secure and safe, because we are not afraid anymore to do some destructive operations, because we always can restore those changes from the stash we created earlier. So now we can experiment with actually some non-trivial operations, and it will be fearless. Let's see the nodes. We already covered stash, and we started covering commit, and we saw the very neat but actually very important feature that not used quite often when I see people working on the Git repositories. It's committing using Hunks. And I think the reason why people don't use it, because the CLI interface is not very easy for this type of job. It's not very easy to commit a hunk using CLI, so they don't use this feature quite often. But with graphical interfaces or textual interfaces like Magit, you can commit hunks very easily, and I encourage you to do it. It's really improve your experience, your Git experience. Other three things related to commit, it's rewriting last commit. What we did here, we committed few Emacs packages, but actually maybe I forgot to commit one more package. I forgot to commit 2 more packages, Smart Parents and Paredit. Let's select this line and commit it. Now, if I jump to staged changes, I see that 2 files are staged, and I don't want RD features file to be staged. I need only one file, and actually only one line of one file to be staged. And this line contains the packages that are missing from previous commit. And now I can create a new commit, and my history will be a little misleading. I prefer to try the history very clean. So when I work on my repository locally, Before pushing any changes to remote repository, I clean up my history. And the first and most simplest trick for cleaning up commit history is amending previous commit. That means that I can change the previous commit without doing some complicated resets and so on. I just stage a few more changes and add those changes to the file by doing commit amend. Here I will be using commit extend, which is under the hood probably commit amend command. Yes, it's commit amend commit minus amend command with no edit flag, which doesn't ask me for commit message. I just add those changes to my previous commit. There also a commit reward command, which is actually also a git commit amend command, which just asks me to change the commit message, but doesn't include any changes from staged area. So here add many Emacs packages. We changed the commit message, and we see the corresponding command which did the trick. Cool. Now we are able to rewrite the last commit, and it's already quite big actually, because many times we don't need to rewrite the whole history of changes that we have in our branch. We just need to clean up some small pieces of our last commit. So we committed something and decided, oh, I forgot to do this, and message not quite good, I will reward it. So we just used git commit with amend flag, or those three commands from Magit interface. Cool. The next two things is squash and fix up, and those things are related to both commit and rebase commands. And rebase command is quite advanced command, I would say, but probably after learning it and becoming a little more fluent with it, you will find it quite easy to use and actually quite useful when you're working on some repositories with few branches where you need to prepare the history before pushing it to the remote repository. And let's cover them when we will be talking about rebasing. One more thing that I will show you today related to committing changes is Transient Git Gutter interface. It's a small package for Emacs I wrote a few weeks or months ago, and it allows to, for example, let's open this file and let's call this interface. And on the left you see the green and blue lines, and also red corners or triangle, which shows part of the file which was modified. Blue one deleted, red one and green one added. And on the right it shows the actual diff for this hunk. So this small tool allows to jump between hunks inside the current file. You're editing something and you decided, okay, maybe I need to stage this part of the file, and you open this interface, tap S button, and this change goes to staged area. Cool. After that, I can go to the Magit interface and see that staged changes actually contain this part of the file, and the rest of the file is not touched. It's quite simple but useful thing when you work on a big file with a lot of changes and you want to commit them atomically because some changes not related to each other, and you want to keep them in a separate commit. You want to keep them in a separate commit. For example, if you later decide to revert those changes, it will be easier to revert a small atomic commits rather than big, which contains a lot of changes which can affect some following commits. Pandemic says that he understood Git with Magit. Actually, it's quite true. Magit is very thin layer on top of Git, so it doesn't hide a lot of things underneath, but it allows to explore my Git much easier, because you have if you learn one command, which is question mark, you will see all of the commands that is wrapped by Magit interface, and those command list is quite comprehensive. It covers probably 99% of any Git workflow that people use. Maybe some very internal things are hidden here, and maybe some of them are placed somewhere under Magit command prefix. But most of all things that people usually do with Git is available here in Magit interface. But we talked about Transient Git Gutter interface for committing parts of the file. It's the same as committing Hunks, but just from the current file, from the current line, which can speed up your interaction with version control system. But it's probably already quite advanced thing that may be not necessary for you. Another thing that people usually do in many projects is creating branches. It allows to separate few change sets from each other and give them a different meaningful names. You can do two things. You can create a branch from the current one, or from some from any other branch. Using Magit interface, you can do it with B hotkey, B, C to create new branch from any specific branch. First of all, we pick the branch that we want to branch from. For example, let's take vip gnome branch, and our name of our local branch. We creating branch from a region repositories branch called vip gnome, and let's call our branch vip gnome local, but we can call it vip gnome and it will be quite okay, but here I want to make it a little more explicit. We created new branch which is equal to a region for now, but we can commit something, commit some random patch, and we see that now our local branch differs from a remote branch, and we can jump back to the branch we was previously, it WIP gigs home branch, and we switch to it, and now we have a different history here, and it also differs a little from a remote origin VIP gigs home branch by one commit. Hi Adolfo. Here we will use a command which allows to change the state of our local branch to the state of the remote branch. Actually, what happened here? I had a branch, I created some changes, committed them, and created patches from those changes. I sent the patch was accepted upstream and applied, and now the remote branch has almost the same commit, but with different hash, and maybe slightly different changes introduced by the maintainer. And now I want to change my local branch to the same state as remote branch. For now, I didn't pull and didn't fetch anything, so my Git thinks that my branch is one commit ahead from the remote one. What I need to make my local Git aware of the changes from remote branch, I need to fetch those changes from the origin. And for that, I will type fu fetch upstream, the mnemonic behind those hotkey. And now you see my local branch is one commit ahead of the remote branch and one commit behind. But you can see that commit messages are the same. But we can find a small difference between those commits. Here you see in the commit body, nothing here. And here we see signed off by Oleg. That means that this commit is applied by the maintainer, and this commit is the one I created. And now I want to make my branch equal to the remote branch. For that, I can do one simple command. I can reset. I can do hard reset or keep reset. Let's do hard reset for now. And we will reset our VIP gigs home branch to the commit of origin VIP gigs home. And now our local branch has the latest commit signed off by Oleg. So our local branch now is equal to the remote branch. And let's explore this reset command a little deeper, because it's quite important thing that can be used in many different situations. Pandemic asks where he can find my Emacs configuration. You can find it on source hut. It's under RD repository. Inside RD directory, features, Emacs SCM. Actually, there are parts of my Emacs configuration in different files in the same repository, which also appears in my final config. Actually, it's a scheme code which generates my Emacs configuration file and also installs all necessary files for my Emacs. And I encourage you to see my previous videos on RD and Emacs to get a little better understanding on what happens in those files. But for now, I will just post a link and you can explore it if you want. We stopped on git reset command. Here we just did a hard reset of our local branch to the head of a different branch. Actually, branches are just labels on some commits. And from those commits, we know that there is a parent of the commit, so the branch can be easily tracked to any commit in the this long list of connected commits. I found a pretty interesting article called Understanding Git, which is actually a series of 3 articles, which explains the basics of internals of the Git, how it stores files, and how those files are connected into more complicated objects called tree objects. And those tree objects also can be connected between each others to make a hierarchy of directories. And the root of this hierarchy can be a part of the commit. And the commit contains the pointer to the tree object and to the parent commit. So from the each commit, we can track all the previous commits to the root commit, which doesn't have a parent. And a branch is just a label. Let me find this thing in this article. Or it's probably in the next post. The second post is about branches, actually. Here you can see that actually branch is just a file which contains the hash of the commit. And referencing the branch by the name, we actually reference this commit by hash. It's the same operations. Referencing by branch label or by commit of the hash. By the hash of the commit, of course. Okay, I will post this the link in the notes for the stream about Git and its internals. Actually, it's not very deep internals, it's just very basic internals which are useful to know. Oops. We talked about one application of reset to switch the current head of our branch to the different commit, but we can do other things. Probably you saw during reset there are few options. First is mixed, soft, hard, keep, index, and worktree. We are interested only in first 4, probably. Other will be pretty easy to understand once we got first 4. What it actually do? It actually changes few things. It changes the state of the head or the pointer of our branch label. It just switches the commit hash to a different one. It will be done by soft reset. It just let's actually do it. For example, we have one commit here which points to the head of our branch, and we want to reset our branch to the previous commit. What we will do? We will do a soft reset which resets the head or the pointer of our branch to the something, for example, to master. What will happen here? Nothing will happen because we are switching to the same exact commit as we was before. and you can see nothing happened. But if we do a soft reset to origin master, we see that origin master is one commit behind our current master. The commit will disappear and our changes will be in the staged area, and we can commit them once again. I will restore the previous commit message using Alt-P hotkey, but you can type it one more time or something like that. And I got the same commit again, and what can I do? I can also do a mixed reset, which will do almost the same, but will place the changes introduced by this commit that we are resetting right now, not to the staged area, but to the unstaged area. And actually, it's what we really want. We want to we want to remove this last commit and to keep our changes in unstaged area. So we resetting to origin master, or also we can reference the commit by commit hash or by the part of commit hash, and we'll be using, let's use actually a part of commit hash instead of name of the branch, and let's do the mixed reset to this commit. Bam! The last commit from our local branch disappeared, and now our local branch is equal to origin master, and the changes related to the Emacs packages are now back in our file right here. Good. We resetted those changes. Now let's do one more reset. The reset called keep reset. Let's commit those changes one more time. I wanted 2 lines here and 2 lines here. Commit jump staged up. We see that we have the commit again. It has different hash, but still the same commit message and the same content. And now we want to reset, but for now we will discard these changes completely from our worktree. That means these changes won't appear anywhere when we doing keep reset. So I reset to origin master, and it shows some problem, not up to date. What does it mean? I'm not sure why it happens. What if I will discard all unstaged changes related to this config file, and we'll try to reset our commit. Okay, now it works. And you see that the configs file didn't appear here, but everything else in the unstaged area still remain. Let's commit, for example, this file rd packages commit many changes. Don't write such messages, they are meaningless. Try to come up with something more interesting. And here we will do a hard reset. Hard reset will do almost the same thing as keep reset, but also will remove all unstaged changes. Resetting to origin master, and boom, the commit removed, staged changes disappeared, unstaged changes also disappeared. And now we have very clean repository at the same state as this commit. So what basically hard reset do? It removes all the changes from Worktree except untracked files which not staged and not under version control right now. And remove all the comments up to this one, to one we resetting. But at the beginning of the video we created stashes, so we can bring back our changes from the stash. That is why I did those reset commands so fearless, because I knew I can easily restore all the changes that I had before. Pandemic says that he finished checking my settings and didn't understand. And he says he use package for manage his packages. Actually, you can't use your system packages with use package. For example, for not much you need a not much binary. For majit you need a git binary, and so on. For ripgrep and all that stuff, you need something from your system package manager or other package manager you use for managing actually binaries, not only a Lisp code. And my Emacs configuration allows not only manage pieces of Emacs Lisp and Emacs packages, but also system packages, and also some configuration of my system which can be related to those system packages. Or not system, my user packages. It's quite big topic, and you can find a few talks about it on my channel. Okay, we talked about reset, and I hope now it's clear what different resets means. And index mean that it will reset only staged changes, and Worktree means it will reset only unstaged changes, and all other we already discussed. They also reset the head of the current branch, the pointer or the label which points to the some commit in our graph, which represent the whole history of all the changes in our Git repository. Good. The latest and most powerful tool is interactive Rebase. So let's do some example commit history. For example, here I commit those two lines and this line, rd example, rd, yep, examples abcdw add a few Emacs packages. Good. Also, let's commit this line, which says rd examples abcd, oops, abcdw add a few home packages. And now I remember that I forgot to commit this one. I wanted, but I forgot. And I say that I want to stage those changes and commit them. But instead of committing as I usually do, let's use commit fixup. And fixup will say which commit we want to fix up into those changes. And we want to fix up it with add a few Emacs packages. Ctrl C, bam. Now we have 3 commits, and let's create one more. One more that doesn't use fixup. We will commit this line, and we'll say add a few more Emacs packages. And now let's do interactive rebase. Interactive rebase will ask the commit that we want to be the latest commit of our rebase. So we basically here we pick in the interval that we will be interactively rebasing from the latest one to the sum of old commits. Let's pick our 4 commits, not to rewrite our earlier history. And it will say that it cannot rebase because I have unstaged changes. For that we have after stash flag that will automatically stash all our changes that we didn't commit yet. And let's do one more time and pick this commit. And our changes got stashed. And here you see that we have a few commits which we want to clean up a little. What we can do here, here you see the hotkeys which corresponds to some commands. For example, R will ask me during rebase to change the commit message. Moving commits will allow to change the order of the commits, and fixup will meld the current commit to the previous one. The oldest commit at the top, the earliest commit at the bottom by default, and after some manipulation with them the order can change, but the overall idea, the current commit can be melded into the previous one, and it can be just melded with losing the commit message of it, or you can be asked to combine those commit messages into one. And here we will just switch the order of those 2 commits as I did, and reward this commit to more meaningful message. And let's continue our rebase process, and now it asks to change the commit message for this commit. And here I will say I add a next latest and F heroes packages. Boom. And now it shows me that there is some conflict, because I switched 2 commits which editing nearly the same area of the file. The conflict appeared. Okay, I don't want to solve this conflict, but actually I can, and I will just commit the changes that will be resulting change, and we'll call rebase continue using RR, or git rebase -- continue in your terminal. But I won't be doing it. I will just abort the rebase process, not to spend too much time on it. I will show you another neat trick that can be used. The problem appeared when we reordered those two commits, which edits the same line, and we won't be reordering them, not to get this merge conflict, but we will do the cool trick. Here you see a fix up at the beginning of the message, and actually the content of this message is equal to the content of this message. And to actually utilize the thing that we did earlier, we marked this commit as fix up for this commit. We need to do rebase with after squash flag, which finds all fix up and squash commits and reorders them in a proper way so they near the commit which will be used as a commit for fixing up. So we do the same thing with after squash, and now we don't need after stash because everything. Oh no, nothing after stashed. We also need to pass after stash flag, and we do interactive rebase. Actually, my pointer should be on the commit I want to do rebase, the earliest commit which I want to be in the list of the commits, and I do one more interactive rebase, and now you see that fix up commit appeared right here near the oldest commit, and it has fix up at the beginning, which means that this commit will be melded in the previous one. And actually this commit is also doesn't have to be separate, and I want to bring it closer to my oldest commit and want also to fix up it or to squash. Let's squash it to show the difference between fix up and squash, and reward this commit as we did in the previous attempt to do interactive rebasing. Now we have 4 different types of commits. This one will be as it was before, nothing changed. This one will be melded in the previous one. This one will be melded in the previous one, but it will ask for the commit message. And this one will ask to change the commit message. Also, we can just stop at the arbitrary commit and to do some other actions, but by using something like Y, or maybe some other key, or maybe B, and we can do some resets, some commits, or some other changes during this interactive rebasing, and commit all of them, and after that continue our rebase and continue applying commits. But let's finish our example here. First of all, it melded the second commit, and now we want to meld another commit, but now it asks for the commit message, and I'm quite fine with original commit message, so I will just remove it, the second message, to discard it, and will commit. So the interactive rebasing will continue, and it will ask to reward the name to change the commit message for the latest commit. And here I will use something more meaningful, add next latest and fheroes packages. Bam. And now you see 4 commits now became 2 commits with more meaningful commit messages and more meaningful content. For example, this one contains all those 3 changes at once. So we wrote our history, cleaned it up, and didn't break anything. And all the time we was sure that we can restore our state to the previous one easily using our stashes. So let's reset the state of my repository. We will be using hard reset, and we will be using origin master. So all the commits are removed, all the unstaged and staged changes are removed, and let's pick the changes from our stash. Yep, and now you see all the changes are safe and restored, and our commit history is completely reset to the original state. That's it for today. If you have any questions, you can write in the mailing list of RD project or on my personal email, or maybe on Mastodon or other social platform or messenger. And I hope your usage of the Git now will be more meaningful, thinkful, and intentional, and you won't be just typing some random comments and hoping for the best, but understanding what happens under the hood and why you type those comments or do some actions in some graphical interfaces. And it will the VCS will be integrated in your development workflow much more deeply, and it will make it easier in the future for you and your teammates to debug and inspect your code, and overall your development experience will become much better. Thank you for your attention, and see you next time. Bye.